I don't personally subscribe to the analogy of it being just like a junior developer. I think that there are things that LLMs do way better and do way worse than a junior developer. And I think key in that is that over time, you expect that the knowledge you're imparting to a junior developer to kind of accrete and accumulate, and eventually they become a senior developer and someone you can rely on to work very autonomously. Whereas the LLM junior developer is going to need that kind of first month on the job level of supervision for its entire existence.
This is DevOps Paradox, episode number 318, WireMock and the Changing Landscape of API Development Tools. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Here we are, it's the beginning of October, and with everything that's happened this year, the guest we're going to be talking to today, we'd actually tried to set it up late last year, but I think waiting till now makes even more sense. We're talking about API testing. And we were thinking about API testing, and I'm thinking through some videos that you've done recently. In the era of AI and distributed systems, one of the videos you did recently was, do we even need higher level abstractions anymore because the AI can figure it out? You were at that point talking about the Kubernetes API.
Yeah.
Think back 9 months ago, we weren't even thinking about this. Now it's like, this is normal.
9 months ago, or a year ago, at least for software engineering, was a gimmick. It was amazingly good at creating Tetris game for Scratch, and that's about it. Now it's a completely different story. Now that generic agents more or less prove themselves together with models, right? Now we are in the next phase, which is, okay, now let's create specialized solutions that actually really excel at something.
So on today's show, we have Tom Akehurst on from WireMock. Tom, how you doing?
Hey, good, thanks. Thank you for having me on the show. And like you say, it's been a long time coming, so it's great to be here.
What do you think about what I was just saying? Now, WireMock obviously is for mock testing. If you've never heard of it, it's primarily in the Java ecosystem, but I think it can apply anywhere. I mean, even if you're not writing Java apps, you could still do mocking, I guess, but we won't go from there.
So yeah, it's probably worth clarifying that WireMock mocks networked APIs. Although its origins are in the Java ecosystem, the core library is a Java library. It's actually completely agnostic to the tech stack you're using because the thing you're mocking is a network interface. Anything that speaks SOAP APIs, REST APIs, whatever, will be able to talk to it. WireMock open source has its own networked interface for configuring it. So even if you're not a Java developer and you want to use the open source product, you can run it as a process and you can configure it via files over the network. And then likewise, we have WireMock Cloud, our commercial offering, which is hosted and is API and UI driven. It's important to make the distinction between that kind of mocking, sort of networked mocking versus object mocking, which is very much tied to the language and technology stack that you're using that has to be kind of language specific.
Thus the name WireMock, not just mock.
Yes. Yeah, the clue's in the name.
The clue is in the name. What do you think, though? You rewind 9 months ago. Where do you think what you do, just in general, was doing? Whereas now in October of 2025, where do you think it really is today?
The current phase of the AI wave has affected us in a few ways. For one thing, it's forcing people to rethink the role and use of APIs in how we build distributed systems. AI agents, LLMs, on one hand, they're quite good at interacting with APIs and figuring things out as they stand. But on the other hand, there are styles of API design and ways that you can build and run APIs which are optimized for LLMs to use. So that's sort of causing people to rethink how they build APIs. And that has a knock-on effect to us because we're involved in, amongst other things, helping people prototype APIs, build simulations of APIs that people use to develop consuming and producing parts in parallel, that kind of thing. So there's that aspect of it, just that there's this kind of renewed interest in APIs and API designers and fresh thinking coming into it. And I think the other side of it is obviously we're a developer tool, and AI, particularly sort of the latest batch of AI coding agents, has really shaken up the way developers are working with code and working with their systems. Increasingly, the AI agent is becoming this kind of primary front end onto how people work. We've been looking at MCP in particular, so the protocol that Anthropic released at the back end of last year, that is a sort of universal interface between AI agents and kind of external tools. MCP allows you to plug tools into your AI coding agent that then allows it to do things kind of outside of the bubble that it operates in. So it can go and look at your GitHub issues, or in our case, it can go and interact with your WireMock cloud account, and you can create mocks in it directly, that kind of thing. This is still kind of somewhat sort of frontier territory. The things that people are actually really going to get value from, that are actually useful, that play nicely with the coding tools out there, is still very much something we're still sort of seeking to discover at the moment. There's some interesting possibilities, particularly the ability to use an AI coding tool as this sort of composite kind of orchestrator for making changes to different parts of a system, and using MCP to plug into the different parts that you need to affect simultaneously. There's potentially a lot of power in that we're only just starting to discover how to take advantage of.
Testing APIs sounds like almost one of the first cases or easiest cases for AI to tackle, right? Because just paraphrasing now, but you can just say, hey, here's the schema, and there is no reason on earth why you wouldn't have schema today anymore. It literally takes 5 seconds for it to be created. So here's the schema, go wild, right? Just do the variations.
Yeah, it's important to clarify as well. We don't actually do API testing in the sense of we don't provide tooling for driving tests into an API, providing a test client. We're flipping it around and we're providing a mock so that you can test an application which is calling out to an API. Having said that, what you just said is also largely true in that context, although you'd be amazed how many APIs don't have any kind of, well, a lot of APIs do have a schema, but you'd be alarmed at how many of them are incomplete or inaccurate. I think the difficulty of getting to one which is really precise and descriptive and maintained and up to date, that's the thing which is still lagging behind in this business. And actually something else that AI helps with as well. It's a lot easier to keep these things maintained when you have tools like that than when you're relying entirely on human beings to do it.
But that's the thing. I'm fully aware how many companies don't have schemas, and many schemas are outdated. But that's such an easy task today for AI to just say, hey, here's my API, the actual code. Create, update, do whatever needs to be done to get the schema. It's so easy today, right? Because there is no thinking. There is no real interaction with the user. There is no, oh, would you like it like this or would you like it like that? It's literally translated from one format to another, because that's what schema is, right? It's a translation of the same API written somewhere.
Yeah, there are some stacks in which that works better than others. I think if you're using languages with very descriptive type systems, then that maps fairly well onto schemas. I think if you're using a dynamically typed language, if you're using ES6 or whatever and writing everything in Node, then getting from that to reliable description of the API can be a lot harder. I think that it's variable. And then also a lot of the tooling out there is patchy. So some very well-maintained projects, often ones that are sponsored by vendors with an interest in the space, and they tend to be fairly good. But then I think there are some language stacks that have things that are just maintained by volunteers who don't have a lot of time. I think this is one of many reasons why in practice it's very patchy. You get some very well-documented APIs and some where the documentation is actively misleading.
If it is misleading, what can those companies or those people do? Or should they just say, effectively put up a robots text and say, forget it, go away?
There are plenty of tools at our disposal. I mean, this is something I've talked about quite a lot in the past. When you start working with APIs at large scale, there are organizations that have hundreds or even thousands of microservices now, and they have a real large systemic problem associated with making those APIs discoverable and available, documenting them in a way that allows other teams, other users to take advantage of them. I think really you need to lean heavily into the kind of automation that we're much more familiar with in other areas where we're constantly maintaining a closed feedback loop. So in practice, with things like if you want to maintain open API descriptions of your APIs, then you need to be regularly sampling traffic to and from those APIs and validating it against your open API. And then when there are discrepancies, you need automated systems that alert people to that, to say your description and your API don't correspond to each other anymore. You need to go and do something about it. And like I say, I think this is where AI tools are interesting because you can often automate a lot of those fixes. We already have some of this tooling built into our product. So you can switch on a validation mode whereby it will pass traffic through the product and validate it against the open API that you've provided. There's a certain amount of sort of automation of fixes that we can do as well. But I think there's a step further than that in the near future where you've got AI agents that are able to kind of look at that discrepancy and say, okay, I can see how to fix that. I'm going to open a pull request against your open API with a bunch of suggested fixes in it. And then the job of maintaining accurate documentation becomes about just kind of reviewing these PRs that are coming in from agents rather than some hapless junior developer having to crawl through field by field every time anything goes wrong.
But isn't an AI agent a hapless junior developer?
Well, yes, a hapless junior developer who never complains, in theory at least.
That doesn't demand to be paid more or have more free coffee or whatever.
And
right?
doesn't sleep.
And doesn't sleep.
I feel like they do demand to be paid more at the moment, judging by the price hiking that's been going on in the last few weeks.
Oh, still, I mean, if you pay $1,000 a month, you're using it more than vast majority of people in the planet, right? Now, even junior developers ask for that amount of money or more.
Yeah, it could turn into a philosophical argument very quickly, I think, shouldn't it? I don't personally subscribe to the analogy of it being just like a junior developer. I think that there are things that LLMs do way better and do way worse than a junior developer. And I think key in that is that over time, you expect that the knowledge you're imparting to a junior developer to kind of accrete and accumulate, and eventually they become a senior developer and someone you can rely on to work very autonomously. Whereas the LLM junior developer is going to need that kind of first month on the job level of supervision for its entire existence. It doesn't seem like an apples to apples comparison to me to compare the two.
But that's assuming that one of those two doesn't improve. Meaning that I take your junior developer and we meet at 10 years from now when that junior developer is a senior developer. And then I try to imagine, okay, what will be happening in this space in 10 years from now? And I failed, my imagination fails me immediately. I mean, I cannot predict even what's going to happen a year or two from now.
This is also true. Yeah, I'm in the same position as you. I can't speculate about that, really. The trajectories for improvement kind of differ, don't they? Whereas the assumption is that the models will improve generally. Their ability to produce the thing that you really want them to do will improve over time. The junior developer will learn your domain specifically. I think it's maybe the difference is that they will fit themselves to your environment and your specific problems in a way that potentially a generic improvements in AI won't yield the same effect.
I'm of opinion that the only way how that area will have to continue progressing is if we figure out how models can learn. If that does not happen at one point, this is all going to end up being pointless, right? Then we are getting into that story that, okay, yeah, but that person will eventually learn. This thing it never, ever learns, right? And I would be very, very surprised if that does not happen at some moment.
Yeah, I think it is happening right now, isn't it? There are tools that have areas of memory that sit outside of your project, I guess accumulate institutional knowledge of sorts. So I think you're right that these tools are developing those capabilities. Obviously, we've had RAG for a while as a predominant technique for bringing institutional knowledge in on top of what the LLMs can do generically. So I think those things are happening, but it still seems like we're in the foothills of really understanding how to make that stuff work at the moment. We've been experimenting with a very basic version of this technique. One of the things we wanted to do with the MCP server was to say, rather than you having to type out these long prompts or having to have guidelines files that essentially just articulate the same sort of good practices about how to build a mock API, we want to encode that somehow in the MCP server so that you can type a much shorter prompt as a new user and we'll expand that out. And actually, as it happens, MCP has this prompt concept that isn't used very much, which is for exactly that, although it seems to be not very well supported by the tools at the moment. Instead, what we've been experimenting with is this idea of having embedded documentation and just an MCP tool, which allows you to go and fetch the documentation. The thing I've been experimenting with recently is the idea of API crawling. So if you have an API, maybe you have some information about it, but it's a bit sketchy. You have the open API document, which is maybe a bit out of date or a bit imprecise, and you want to say to the AI, go and figure this out for me, go and make a bunch of requests, try and get to the point where you've made successful requests, and then capture the results of that and update my documentation and update my mock from it. So there is embedded in our MCP server, essentially this kind of article that's describing the process of crawling. This is how you do it. This is how many times you try things. These are the success criteria. So now if I type in a prompt saying, go and crawl this API from me, here's the base URL, here's how you go and get the credentials, then it will go and say, oh, okay, I've got a document about that. I'll go and read it, expand all of that into the context, and then hopefully do a better job of it than if we just started with the user prompt and nothing else. I think there's a bunch of different ways to sort of skin this cat. I'm not saying that we've got it perfectly right yet, but that definitely helps get a better outcome for the user than if you're just taking their prompt and nothing else.
Why would somebody really need to go ahead and use WireMock? Like, it seems like I'm used to mock objects, but I'm trying to figure out, okay, why would I need an engine for something like this?
There's a bunch of reasons why. First of all, it's a complementary technique to mock objects. There are places where mock objects are absolutely the right thing to use, and I think there are places where they're not the right thing to use. Starting at when you're in your inner loop, when you're writing tests and test driving some piece of code, there's a very old heuristic in mock objects, which is that you shouldn't mock types that you don't own, that the originators of mock objects talk about as a kind of maxim that they stuck to, because they found that whenever you try to mock things that you don't own, you get into all kinds of trouble with the mock being unrepresentative of the real thing. And HTTP clients are a particularly good example of this. They tend to be really difficult to mock well with object mocking tools. And you end up writing tests which are throw up false positives, are misleading, harder to maintain, all of that kind of thing. Yeah, often in modern systems, very distributed systems like microservices, a lot of the complexity is in the integration layers of the code rather than the core domain. And by mocking things sort of at the network level rather than with mock objects, what you're allowing yourself to do is write tests that exercise all of the production code that you'll be running for real. A really common pattern for using something like WireMock is you kind of start up like your entire microservice in pretty much the form that you would run it in production. It's just that you've configured some external endpoints that it calls to for local web addresses rather than the actual domain names of the APIs that they talk to. It's amazing how many additional bugs that you can find with configuration, with sort of the way serializers are set up, with you find concurrency bugs, things to do with threading and so on like that, that when you use mock objects, you're sort of eliding all of that stuff from the information you're gaining. So it's a very powerful technique in that regard. It allows you to, particularly when you have the situation where a new API is needed or a new API feature is needed to support some new product feature. So producing and consuming teams might come together and co-design it, but then initially there isn't an implementation. The producing team has to go away and build this new API, and the consuming team doesn't really have anything to work with at that point. And yeah, granted, they could write some mock objects that are sort of proxies for how the API will be structured. But again, prototyping the API in a mocking tool, what that allows to happen is for something which is far more realistic simulation of the real thing will emerge. Client teams can start integrating with it and testing its validity very early. And again, you'd be amazed the extent to which you catch defects in your API design, ways in which it just it's not fit for purpose for the feature that needs to be built in a very early, less shifted way. Because the alternative to that is you wait for the API team to go off and do their thing. They spend a few weeks building this API feature. They ship it into a test environment. Then your front-end team, your mobile team, whatever, start coding up a feature. And they go, oh, hang on. We completely missed all of these bits of data that we're actually going to need for this. So can we feed this back into the design? And then they sit on their hands for another few weeks while this cycle occurs again. It's a great productivity aid, and it's a great quality aid in that regard.
It seems like to me, if you're a producer, I'm going to use your word producer, of a back end, should I be creating my WireMock of that before I actually create the new thing? I mean, it seems like I need to create my spec that then produces the WireMock that then produces the actual.
This is the way a load of our customers work, is when they have these co-design sessions between producing and consuming teams, they'll build the mock as they're having the discussion. WireMock's unit of work, I suppose, is essentially a stub, is a request response mapping. So it says, if we see a request that conforms to these criteria, then here's a recipe for producing the response. So they're examples, really. And teams will build up a set of these examples that represent the behaviors that they think they need for whatever feature they're building. In that workflow, we'll produce the open API for you off the back of those examples, kind of as you're building it. So you have sort of an initial draft of the spec will emerge as you're creating these examples, which you can then take away and you can feed it into your governance process. If you have one, you can tidy it up and enrich it and refactor it and that kind of thing. Yeah, this is a really productive way to work for a lot of organizations, and particularly where you have potentially multiple teams as stakeholders to an API design by following a process like this and having the simulation as the kind of produced artifact reduces a lot of ambiguity about what it is that you're producing. You know, the producing team have got the spec to work from, consuming team have actually got something they can integrate with and build against, and where they can, like I say, they can provide that early feedback.
So I'm going to take us back to the AI part now. Shouldn't we be using AI to help produce the Open API spec? It's got a lot more knowledge than probably any human will ever have about it.
Yeah, it can work very well to do that. AI is very good at it's good at producing small amounts of Open API. This is the thing I stumble across the most, is that Open API documents tend to get very large very quickly and exceeding token limits or context window limits very quickly. So it's not a completely solved problem at the moment. But having said that, in terms of, you say, I want you to create me a new endpoint in the spec for creating a new draft invoice, something like that, and I want you to include these fields in it and any other metadata that would typically be associated with it. And it will generally nail that pretty well. I mean, this is one of the things we support through our MCP tooling. So you can just tell it to go and do that directly, build a mock and the Open API just directly in your cloud account. So yeah, this is definitely a good way of avoiding a lot of the grunt work involved in authoring these specs. Because I think in the past, even teams that have followed a design first process where the authoring of the Open API is the first thing that you do when you're producing new API features, it's very labor intensive. There's traditionally a lot of work getting from that kind of abstract description of what you really want down to a detailed spec format. So yeah, AI is very helpful in that context.
So it's curious to me that as I've gone through and have worked on things that are not mock or WireMock enabled or whatever, I've received ideas from the AI interactions. I was like, oh yeah, I probably should include that. I wasn't even thinking about that. That wasn't even in any discussions we've ever had. Where does that put us now? We thought we were seniors, but yet here's this hapless junior developer that has the knowledge of the world at its fingertips faster than I can get there.
Yeah, although as a senior engineer myself, I find that the junior engineers in my team still surprise me in that way fairly often. Ideally, you want a team that brings together a bunch of different perspectives and is a room full of people who will all be saying the things that somebody else didn't think of. And I think the AI kind of adds an extra string to that bow. It is very useful in that regard. I mean, I've spoken to a lot of people who don't use AI for generating code or artifacts directly, but as this sort of ideation partner. So they'll kind of say, I think I want to do this, ask me some questions about it, and then give me some ideas about how this could work. Really what they're doing is kicking things around and eliciting these things. What are the things I haven't thought of? And then they go away and build that. And I guess the other positive effect it has is, this isn't a universally positive thing about AI. I think it has this sort of homogenizing effect in a lot of ways. One thing a lot of people have talked about is how the most popular frameworks, the most popular languages, the most popular programming patterns, the ones that are most represented in the training data of the LLMs, are always going to be the ones that end up being generated or represented by it. But I think where it comes to things like API design, this is definitely a good thing, because really you want your API designs to use a bunch of familiar idioms. If there is a most popular way of structuring an address object or doing pagination, there's a number of different ways of doing it, but there are certain sort of popular patterns that are adopted. If you're not sort of intimately familiar with all of those patterns and you're trying to design an API and you ask the AI to do it, you're probably more likely to get something which is going to be familiar to end users because it's well represented in the training data. Whereas I think one of the problems with API design in the past has been engineers kind of winging it and making up ways of doing things that are not consistent with other designs, and where consumers of those APIs then have to go and learn something which is not idiomatic in order to make an API work. So I think AI, I hope, will have this positive effect in sort of smoothing that out and homogenizing API design over time.
Also, part of the problem is precisely that models are trained on public data, and public data is crap. Right? If you just say, hey, what is the most commonly way to do something? By what is, which of the 5 options occur most often on internet, that is definitely not a criteria that would provide certain level of guarantees that actually that's the right way to do it, right? The fact that everybody does it like this does not mean it's a good way to do it, right?
There are certainly cases where that's true. I mean, it's the most upvoted thing on Stack Overflow, isn't it? That was the pre-AI version of that problem, where you'd have some absolutely terrible answer, some awful piece of code which has been upvoted 1,000 times anyway, because it kind of worked for everybody that pasted it into their IDE. This becomes idiomatic, even though it has no right to. I get what you're saying.
Not only that it worked for a majority of people, but when I go to Stack Overflow, the first result looks like something I will need. I'd get it. It's most upvoted. And guess which one I upvote myself? That first one. Whichever comes to the top is what everybody's going to copy and paste and continue upvoting. That's the game over, kind of.
Yeah, it's true, isn't it? I mean, and you see that effect all over, that kind of gravitation around the first mover. I think that's kind of the way the internet works in general, isn't it? And AI is just a sort of a reflection and an amplification of all of that. I think that it's a mixed issue. I think in the case of picking on pagination, because I've been thinking about that recently, but there are several ways of doing it. They're all kind of okay. It's not like any of them is particularly bad or good, but you kind of wish everybody would just pick away and stick with it and pick a set of parameter names and stick with them, rather than it being sort of similar but subtly different every time, and you having to, do you know what I mean, write all this bespoke code which is just about solving the same problem over and over again. And like I say, it's the thing about just pick something and stick with it. I don't care what the solution is in that case. So I'm hoping in those instances, the AI's kind of homogenizing effect is going to improve matters. But yeah, I can see that there'll be many other cases where the opposite will be true.
But then in that case, if AI homogenizes things, and if AI pushes for the things that are most commonly used and what's not, does that at the same time means that actually no new players can enter the scene anymore? But because let's say you have a tool for X, right? You just came up with that kind of tool for X. And there are already 5 players in X. You will never be recommended. You will never be used by anybody. Ever. Right? And you never get to that first equivalent of the first thumbs up in Stack Overflow, right?
Yeah, I think there is a danger of that, definitely. And again, this isn't a completely novel risk, because I think Google and SEO, Google ranking was the kind of equivalent of this in the past. But I think AI definitely kind of concentrates the problem even further and provides a further advantage to entrenched tools. And I'm laughing because I've had more than one conversation with investors where they actually quite like the fact that this is happening with respect to companies that are built on open source tools that are already well established in the training data, let's say. But yeah, I think there is if I was a new, for instance, a developer tool engineer kind of, if I was starting out with a new product, then I would be scratching my head a lot at the moment about how do you overcome the sort of incumbent gravity that AI creates and find new ways of promoting tools. And I'm sure people will find ways around this. And the thing is, I suppose, ultimately, LLMs, in terms of how they choose to promote things or not, kind of work in a not totally dissimilar way to Google. It's ultimately an SEO problem to try and get people to try stuff. And I think eventually people will wise up to how you can do SEO for LLMs and get their tools promoted, even if they're not the most established one around.
Yeah, but here's a big difference, right? That if I go to Google and search for how to do pagination with APIs, the first one will be the same as what we spoke. But there is still second and a third and a fourth and a fifth. And vast majority of people will not go to those, but some do. Now, if I do the equivalent in models, can you do pagination for me? There is no third, second, third, fourth, fifth. Simply, oh, yeah, of course I can. Here you go. Is it working? Yes, thank you so much.
You're cutting off the long tail of alternatives, aren't you? Yeah, I suppose that's a valid point. I guess it depends how you're using the LLM, doesn't it? If you're asking it, can you give me some alternatives for this? Then it will. But if you're saying, just do this for me via some sensible means, I don't care, then yeah, you're right. You'll essentially be telling it. Someone was saying this the other day. It's like the I'm feeling lucky button in Google, isn't it? Where you're just saying, just give me the thing. Don't give me a bunch of options. Just whatever you think the thing is, give it to me. That's the implicit sort of default mode in which LLMs work, particularly when you're asking them to generate code. They're saying, okay, I'm going to take that top of Stack Overflow answer and munge it into your code base, unless you ask me to do otherwise.
I mean, personally, already abandoned a couple of formats that I'm one of the very few people using, like Nushel. Nobody knows what it is, right? Nobody uses it, and I love it. And now I abandoned it myself because it's rubbish. I mean, it's rubbish when using it in Cloud Code, right? Simply, I get 5 times worse results than if I use Bash. And before that, it was the opposite, right? Nushel, amazing, right? Yeah, you're the only one who likes it. But now I'm almost forced to abandon things that I held very dear, but things that are obscure, less common.
Yeah, I'm trying to think of specific examples. I'm sure I've spoken to other people who've mentioned similar things, that they can see that their favored tools are kind of atrophying because of this sort of consolidating influence of AI. So yeah, I can absolutely believe that.
This homogenization, though, man, it's the senior in me, the almost 40 years in this business in me is going, but that's not how you do things. That's not where you get innovation from. But I'm slowly but surely relegating myself to, you know what? Do we need innovation anymore? At least when we're writing just normal, quote unquote code.
Yeah, I mean, you hear people saying that actually programming language design features start to matter a lot less, and their kind of ability to being LLM generated starts to matter more. It's not so much that the innovation stops, but sort of the locus of innovation moves away from the language design itself, or at least in the way that we're familiar with it, that sort of language design becomes less of a human concern and more of a machine concern. I guess in the same way as there was a point in time where CPUs were designed with instruction sets that were meant to be kind of user-friendly. So everyone talks about the PDP-11 being the kind of high watermark of programmer experience at that low level. And then after that, when the C compiler came along, nobody cared. The compiler did all the messy, heavy lifting of turning the human artifact into the machine artifact. And so then chip designers were free to come up with these instruction sets that were kind of optimized for compilers, for machines to talk to rather than for human beings. And again, this is the subject of speculation at the moment, I think, but people talk about the fact that the programming language is being sort of pushed beneath the place where there's a human being interacting with it. And the LLM's interface is now the human interface. So the innovation is around the tooling from getting from that new human interface down to something the machine can consume.
I mean, it seems like the higher level languages, in theory, could go away, and we end up with either bytecode or just raw assembly. I mean, at the end of the day, it's all assembly anyway.
Yeah, it's interesting, isn't it? Because the only counter to that, I would guess, is that they're still large language models, right? They've still been trained on things which are linguistic constructs that are human created. And I guess if the high-level languages went away, then there isn't a corpus of training data that matches textual descriptions of things up with, this is some code to generate. And I guess also high-level languages, they're not just about us being able to type in human-friendly text, but they're also full of all of these abstractions. Obviously, if you're writing assembly, then it's unabstracted, low-level code that is harder to produce generally for that reason. So it feels like something resembling what we have now is going to have to continue. But whether there are changes in the way languages are designed or ultimately changes in idiomatic use of them over time, I'm sure it's probably happening already. There are other people much better qualified than me to talk about it. But yeah, the way in which those languages get used is undoubtedly going to change, because in the same way as I described with APIs, people are talking about how they're shifting to be more LLM friendly, doing things like providing much more denormalized local context in every API interaction, rather than being, normalized and non-repetitive in the way that human programmers we like. I expect there's probably a whole load of analogs to that and more within programming languages as well.
Well, I think we can agree that APIs are here to stay, probably even more important now than ever.
Yes, I would agree with that. It's hard to see this sort of universe of kind of AI agents doing everything for us is going to flourish without APIs in some shape or form being the foundational infrastructure layer, because AI agents need to do things and they need to interact with the world outside of their own bubble, and APIs are the way to do that. But how this happens is still something that's emerging. The last year or so, the onset of AI agents has really shown how sort of inadequate a lot of products APIs really are. So you have your web interface that does everything the product does, and it makes it easy for users to onboard themselves, to become a customer, to do something, to complete a transaction. And in a way where they can discover their way through it. They can turn up to the website and know how to interact with it and complete whatever task they want to complete. And trying to do the same thing with an API by comparison is really hard. A lot of companies put all these barriers up. You have to go and register yourself. Maybe you have to go and talk to someone in biz dev or sales to even get an API key before you can start using it. Then you find there are certain features that aren't available that way. In some quarters, there's a battle going on between the AI people saying, we're just going to start scraping the website because that way we can get access to it easily. We're not getting rate limited. We've got access to all the features. It's self-describing in a way the API is not. So the AI can actually interact with it more easily than it can the API. So then you've got people putting bot blocking and all that kind of stuff to counter that. And it feels like some equilibrium is going to have to be found in this eventually, where API design evolves so that the API really does have kind of parity with the human interface into every product. to prevent this kind of arms race going on between website owners and AI agent makers.
I'm glad you brought up scraping. We won't dwell there too long, but scraping will never go away unless we get rid of the UI. Could we see a future where there is only a text prompt and that's it? All we're producing now are APIs that are well used or have good contracts, for lack of a better term, so that the AI agents can do their work.
I think there's a place for that, but I personally very much doubt that that will be the only thing available. There's still going to be a huge amount of the kind of APIs that we already know and familiar with, partly because of things like volume of transactions, right? You don't want the overhead of doing inference in every bit of compute that you're doing. Quite often you have APIs which are doing very high volumes of traffic, doing very deterministic, often quite simple stuff, but at a very high volume. So you look at e-commerce websites, constituent APIs on Black Friday. You don't want AI kind of anywhere in the mix in that when you've got just thousands of transactions a second happening. And I think there's going to be that kind of universe of API-mediated interaction, which, if anything, will grow. I think the presence of AI and the new products that it will drive and all that kind of thing will also drive an increase in the sort of traditional style of API usage. But at the same time, I think there will be this additional agent-focused new style of API that is still evolving at the moment, and that will be, I guess, ideally will be designed to stop you wanting to go and scrape the website with an agent. So if you're a travel booking website and you decide that you don't just want tons of agents crawling all over your website in a way that you can't really control, instead you'll say, okay, here is the API for agents. It's specifically optimized for them so they can show up, they can register themselves, they're not blocked by some human interaction, and we are sanctioning this. You can interact with it this way with our blessing. We won't block you or anything like that, but you have to use this rather than scraping our website. And I think that's going to grow a lot as well, that kind of class of API.
Well, isn't that where WireMock could come in and help with this? Instead of having to build out the full thing, it's like, you want to do this kind of work? Go to this endpoint. It's unfettered. You're not going to be hurting us, and we're not going to be cutting you off.
Yeah, absolutely. I think one of the things that WireMock supports is prototyping APIs that don't exist yet. And I think particularly when you're building agents and you don't really know how well they're going to get on with your API design, being able to rapidly prototype, being able to say, okay, we're going to formulate this endpoint in this way, run the agent with it, see if it can actually make sense of it. Oh no, okay, it didn't. It tried to call it in the wrong way several times, so we're going to reformulate it differently. Being able to support that kind of rapid prototyping process, validating that your agent gets on okay with it, is really important. I think it's a lot easier than shipping lots of different versions of the production API before you find out which is the one that's going to stick.
So WireMock can be found at wiremock.org. That's the open source side.
Yep.
There's also the commercial side, which is wiremock.io.
Yep, that's correct.
Now, you sort of talked about it, but give us a little bit more of a pitch on the .io side of things.
So I've been doing the open source project for a long time. Quite a few years ago, sort of around the time microservices started coming to the fore, I started noticing that there were organizations who had been using it for kind of what I think of as inner loop type development, sort of unit and component type testing, using code-driven mocks to support the building of code. Teams who were already doing that wanted to start using WireMock in this sort of broader context. So they wanted to deploy it into integration environments where maybe you had a mix of mocks and real systems, where maybe you wanted to test collections of closely related services together, but kind of isolate them from the rest of your environment. So you didn't have to stand up a 500 microservice environment just to test these 3 services you cared about in the middle. So there's those kind of problems, those using it for performance testing, for other kind of non-functional testing, sort of facilitate these cross-team workflows where you had producers and consumers in different teams who wanted to collaborate around an API design. So we started seeing teams building their own infrastructure, their own supporting configuration management systems, even building custom UIs over the top of it to support all of this stuff. And the commercial product is really an attempt at saying that you don't need to go and keep building this stuff over and over again. We'll give you the tools that you need to use WireMock in an enterprise context and a microservices context like that. It's hosted in the cloud, so you can just spin up a mock API and it'll be on a public domain name. As I mentioned before, it supports this prototyping workflow and this bidirectional generation of open API. There's a bunch of advanced features that you tend to find you need more when you're in mixed environments. So one that's been most popular recently is the ability to do stateful mocking. So capturing bits of state in one interaction or generating state in one interaction and then checking it or consuming it down the line. And what we found is that the broader the scope of your testing, so if you're in a mixed environment where you're testing a bunch of services and you've got some real and some mock services and so on like that, then being able to maintain state across multi-step interactions becomes really important. Whereas when you're doing unit-ish tests, then you can get away a lot more with stateless mocks because the scope of your test tends to be narrower and focused on single state transitions and that thing. So yeah, it's really about when you want to scale up your use of mocks into that larger environment, and where, as I also mentioned earlier, when problems of things like maintaining your mocks and making sure that they remain true to the real thing, when you're only doing a bit of mocking, it's kind of easy to do that. But then when you have hundreds or thousands of microservices and everyone's got their own mocks of them, you have this combinatorial explosion of mocks to maintain. And, we also aim to help you with that, when that starts to become a problem at the scale that you're using it.
So all of Tom's information will be down in the episode description. And again, WireMock can be found at wiremock.org for the open source, or at wiremock.io for any commercial needs you might need. Tom, thanks for being with us today.
Thank you very much for having me. It's been great talking to you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.